Okay, so we're going to talk about the difference between permutations and combinations. Yeah. Okay, so again, we have the videos on page 41 in the book. Permutations and combinations allow you to figure out how many possible combinations or events can be when you occur at the same time. So, like, okay, if we're going to the ice cream store and we're going to get 3 scoops of ice cream, and there's 31 flavors. Permutations and combinations will allow us to figure out how many different bowls of ice cream you could make with 3 scoops out of all those flavors. Okay, now if the order does not matter, it's a combination. If the order does matter, it's a permutation. Things that make the order matter. If you're creating a pin number, the order matters, right? Because you can't just have 4 digits in any, like you can't have the same 4 digits, but put them in any random order and it'll work. They have to be in the correct order also. Security codes, passwords. If you were making a sandwich, the order could matter because you'd have to go bread and then meat. You know, you got to layer it correctly. You can't do like meat with the bread in the middle and some mustard on top. Like it wouldn't work, right? The order matters. But but it would just be messy. Okay, things where the order doesn't matter. If you're going to a salad bar and you've got a bowl of lettuce and you're figuring out how many different salads you could make if you put 5 toppings on it or something, it doesn't matter what order you put the toppings on. Or choosing your outfit, it doesn't matter what order you select the parts of your outfit in. Does it matter what order you put them on in? Sure, you can't put your shoes on before your pants, but when you're picking out the order, doesn't matter. And then if you go get ice cream sundae or whatever, it doesn't matter what order they put the scoops in the bowl. Technically, it doesn't matter. So when the order matters, it's a permutation. When the order doesn't matter, it's a combination, and there's 2 different kinds of math. You're going to get 2 different results on these because that order mattering is going to change things. Any questions so far? We have the fundamental counting principle, and this is actually a theory. It's a fundamental theory, which means it's been proven, it's going to be the truth no matter what you do. It's a fundamental math theory, which means that all math is kind of based on these kind of things. It's one of the foundational theories that math stands on. Okay, if an event can be chosen in P different ways, and another event can be chosen in Q different ways, then the number of ways that these things can occur is P times Q. So if I'm picking out, for P, I'm picking out what shorts I'm going to wear. And for Q, I'm picking out what socks I'm going to wear. They're independent, right? Because socks and shorts, like, they don't affect each other, unless I care about matching, which in this example, I'm going to say I don't. I would have, let's say I have 15 pairs of socks, and I have 3 pairs of shorts. The different combinations I can pick with the socks and the shorts is 15 times 3, so I can make 45 different combinations of socks and shorts. Okay, so it tells you how many ways you can arrange the items. That's the fundamental counting principle. Now, if you have permutations, you have the possible arrangements in an ordered set of objects. Ordered being the key here. They have to go in order. And the notation for that is NPR. N is the number of objects. R is the number of objects chosen. So let's look at, say, the lottery. So was 53? We'll just pretend. I don't remember. It was 53, let's say. It's 53. Okay. 53 in the lottery would be our N. That's the possible number of events that can occur. 53 different numbers can happen. But we only picked 6 numbers for the lottery? 6. So R would be 6. So for the lottery, we would write 53P6. And that would be the math that we would conduct that would tell us how many possible lottery number combinations exist. Since every number can only come up once in the lottery, that's how many different possible exist. It's ordered. Everything can only be used once. Whereas with a combination, let's say the lottery number 54 or 44, if it was a combination, you could have 44 chosen 6 different times. Obviously, that can't occur in the lottery. So it's a permutation. So if n equals r, so let's say there's 6 numbers, and we're going to pick 6 of them, then you get what's called n factorial. This exclamation point is the factorial function. Okay. And factorial means I'm going to take 5, and I'm going to multiply it by every number under it till we get to 1. So 5 factorial is 5 times 4 times 3 times 2 times 1. And 10 factorial is 10 times 9 times 8 times 7 times 6 times 5, 4, 3, 2, 1. Okay? And then when you multiply those out, they grow really fast. Okay? So factorial is you take any number, put an exclamation part after it, and that means to take that number and every number less than it and multiply them all together, stopping at 1. Because you can't throw the 0 in there, because if you did, what would every answer be? 0, right? So it's a general rule that 0 factorial is equal to 1. 1 factorial is also equal to 1. I don't know why they said 0 factorial equals 1, but they just did, and so we just say, okay, fine, thank you. We'll learn that then. So if you have the same number of possible objects as the number you're going to choose, and you're going to put them in a certain order, so we're going to say like 6. Okay, so we'll say I have 6 objects, and I'm going to use all 6 of them, but I'm going to arrange them in order. I can figure out how many different ways I can arrange these 6 objects. That's a permutation, will tell me that. And then it would be 6p6, but since these are equal to each other, it's just going to be 6 factorial, which means it'll be 6 times 5 times 4 times 3 times 2 times 1, which makes it 120 times 6, so it's 720. So far okay? So if these two numbers match, just take the factorial. I'm going to show you how to do that on our calculators that we have in class, and then I can show you how to use them on like an iPhone or whatever. So on the TI, it's a TI 30XS. That's what this is. Okay, they're a little bit different. It's a little bit different if you're using a TI. Any TI 30 will be about the same. They might be slightly different. And then if you get into the TI 80s where you've got the graphing capabilities, it's a little bit different there too. And I can show you pretty much on every calculator how to do this. But for the TIs, the first thing you want to do is you're going to press this button right here where it says PRB. Probability. PRB. Okay. When you do that, you get this screen right here where it says PRB and RAND, and then you've got NPR, NCR, and 3 with its factorial. So here's a close-up of what this screen looks like. We're going to choose the exclamation point. So what you want to do is you'll pick your number. So let's say I want to do 11 factorial. I'll type in 11, I'll press the probability, and then I'll press 3. And it gives me that. And then I get my answer. $39,916,800. Do you need to use that button to do a factorial? No, you can do 11 times 10 times 9 times 8 times 7. But you're going to see, like, if I told you to do, like, 200 factorial, that would take a really long time. On an iPhone, or probably any Android, if you turn your phone sideways, you get the scientific calculator. And there's, on this side over here, there's X with an exclamation point. So you'll put in your number and then hit that button and you get the same answer. Okay, so that's how you'll do a factorial on this phone. Okay? Any questions on computing a factorial? Okay. Most scientific calculators will have a factorial button somewhere on them. So if you have a different calculator and you don't know where it is, let me know and I'll come look at it and see if I can't help you find it. Okay, so what do we do with this? How many ways can we arrange the letters in the word math? Well, we have 4 letters. And we're going to use all 4. And here's what's actually going to happen. The first letter we pick, we're going to have 4 choices. But then the second letter, we've used 1, so we're going to be down to 3. And then the third letter, we've used 2, so we'll be down to 2 choices. And then for the last letter, so that's the 4th. I should have just written 4th. Anyway, there's only 1 left. We have to use that 1. And what happens here is I have 4, 3, 2, 1. So my possible number of arrangements I have 4 letters. I'm going to use all 4 of them. So 4 factorial. So I can actually arrange these letters 24 different ways. Now, are they going to all make words? Absolutely not. But that's okay. We're not talking about to make a word. We're talking about how many different ways can you arrange 4 letters. So, you know, one of them is going to be like HTMA. Not a word. Don't care. Yeah. Okay. Any questions on that one? So when these 2 numbers, again, remember it's NPR. This is the total number, and this is the using number, how many you're using. Okay, and when they're equal to each other, you just calculate the factorial. So far, okay? Sometimes P and R are not going to match. The lottery, right? We have 53 numbers, but we're only going to use 6 of them. When that happens, we use this formula, where you take n factorial, so the total number of possible to the factorial, divided by n minus r factorial. Remember that this is n, this is r. They go alphabetically, n, r. Okay. So you're going to need this formula. So if I want to solve for 6p3, so I'm taking 3 objects out of 6 and calculating the permutations. I have 6 factorial divided by 6 minus 3 factorial. Now, it's not 6 factorial minus 3 factorial. Remember, you have to subtract first and then do the factorial. So this is 6 factorial divided by 3 factorial. An interesting thing will happen here. Yeah. When I subtract it, the answer I get, all this stuff is going to cancel each other out. And it doesn't matter what size. If I did 20 factorial over 3 factorial, the 3 part would cancel out. Or if I did 20 factorial over 15 factorial, from 15 down would cancel out. So basically, you know, this part all goes away. So now you do 6 times 5 times 4, which is 30, times 4, which is 120. Okay, so if I have 6 different objects and I pick 3 of them, there are 120 different possible ways I can make that combination. Okay. Just real quick, you know those keyless entry door locks? Okay, let's say no numbers are allowed to repeat. Okay, which you can repeat numbers, but that would be a combination, not a permutation, so we're doing permutations, so nothing can repeat. So we're going to do a keyless entry. Okay, we have digits 0 through 9, so there's 10 digits. Yeah, there's a 0. And let's say we're doing a combination of 5 of the 10. Do you want to do 5? 4? Okay, we're doing 4 numbers. And we're going to say they can't repeat. Again, because if they can repeat, it's a combination, and we're doing permutations right now. So we're going to do 10 P4. So that's 10 factorial over 10 minus 4 factorial. So that's 6, right? Right? You get it? Times 5 times 4 times 3 times 2 times 1. Those are all going to cancel out, so I have to do 10 times 9 times 8 times 7. So I'm going to do that really quickly. 10 times 9 times 8 times 7. There are 5,040 possible combinations. So this is why those are secure. Because and most of them you can do a 4, a 5, or a 6 or more. You know, you can pick how many numbers are in your combination. So like if you do, and most of them you can repeat numbers. So if you think about that, if you use 6 numbers and you can repeat numbers, how many? That's huge amount of combinations. Yeah.
What if you can? I know on the iPhone you can do words and.
Yeah. Yeah, you can do that on some of those too. Well, the keypads usually will look like the old telephones where, you know, ABC is on 1. So it's kind of a number. You use a word, but it's really numbers still. So you'd still only have 10 possible digits that you're using, even if it's 26 letters, because there's only 10 keypad numbers. Does that make sense? So like A, B, and C would be on the same button, so it would count as 1. And then, yeah, so, but there's 5,040 possible 4-digit combinations where you don't use the same number twice. And somebody's trying to break into your house. I'm thinking somebody's going to come along before they get through all 5,040 possible combinations. You know, that's going to take too long. So that's why those things are secure. Okay, now, do you have to do it this way where you cross things out and... No, you can actually put this into your calculator and you can take 10 factorial and you can divide that by 10 minus 4, so 6 factorial. Oops, it helps if I push the right button. And that gives me the same answer. So it's up to you which way you want to do it, but it works out the same answer. Okay, let's try something else. What is the total number of possible 4-letter arrangements of the letters for the word snow if each letter is used only once? Hey, we kind of already did this with the word math, but we'll do it again. 4 letters. We're going to use all 4. Uh-huh. So it's 4 factorial. So there's 24 possible arrangements. Now here we're going to have a committee to be formed with a president, a vice president, and a treasurer. Okay? There's 10 people to select from. So 10 is the total number of people, and we're going to use 3 of them: president, vice president, treasurer. And we want to figure out how many possible combinations of this committee can there be. And so we have 10 divided by 10 minus 3 factorial. So okay, 10 minus 3 is 7. See, I don't have to really do that because you guys know these match. I'm going to cross out everything from 7 down because 10 minus 3 was 7. So I have 10 times 9 times 8. So there's 720 possible committees that we could make up. Okay, so any questions about general permutations? Okay, keeping in mind that with a permutation, everything can only be used once. So, like if we're making a combination of digits, only can be used once, can't be repeated. Okay. Now, if it was already twice in here, so instead of like snow, it was snow with 2 O's, so it was like snoo. Then you would count the O twice, so it wouldn't be 4 and 4, it would be 5 and 5. Because each O would only be used once, but there's 2 O's. Does that make sense? So repeating letters and repeating numbers are okay if they're in your original set. You just don't repeat them if they're not repeated already. Does that make sense? So if the word was moon, it would still be 4 and 4 because you have 2 O's, but you use both O's. Right? Okay. But if it's mun, for short for Monday, you can't put 2 O's. You can't use O twice. You can only use it once. That's the end of section 2. Now we're going to do some more permutation stuff. Permutation problems. We're going to solve things using permutations. Now, we don't have graphing calculators. Okay. In the classroom for our class set. Because a class set of graphing calculators is over $3,000. And I'm not going to make you guys buy graphing calculators because they're over $100 each. Okay, so if we're going to solve probability problems where we're going to use the probability function in the calculator, first thing we have to do is we pick the number for n. So first step is input n, whatever number that is. Your second step is to press the probability button, which is this button right here, probability. Then you choose 1. So let me put that over here. Which is NPR because that's the kind of problems we're doing. Then you input the R number, and then you press enter. We cannot do that on these phones. Now you may be able to download a statistics app calculator. Like, I don't know, I haven't looked. But there may be a statistics calculator app that exists, in which case you'd be able to do this on your phone. But for right now, we're going to have to use these. And this will also be online. So let's, the R number. yeah, whatever the number is for R. So let's say I'm doing 5P2. I'd push 5, and then I'd press the probability number. Then I'd press 1, like the number 1 for picking 1, and then I put 2 for this one, 2, and then I press enter. So I'm going to go through that on this. So everybody got that? Okay. So let's say we have 9P5, okay? So I have 9P5. So step 1, I'm going to press 9. Oops, 9. I pressed 9. Step 2, I press the probability button. Step 3, I choose NPR, which is the first one, so I enter the number 1. And then step 4, I enter 5. And step 5, I press enter. And my answer is 15,120. So if there are 9 objects and I choose 5 of them, there are 15,120 different possible combinations. Now you remember out of 10 objects there were 5,000 if we chose 4. So you can kind of get an idea of, like, if you pick a 5-digit security code, why it would be hard for somebody to hack that. Do they? Okay, cool. I figured there's some, but no, I was going to do that this weekend and I didn't. Mostly because I didn't bring the old test with me. And so I said that the new test would be like the old test, but a little bit different. And if I didn't have the old test, I couldn't do that. Okay, guys, on the homework, the directions that they give you on page 6, I want you to look at this really quickly.